In this video, we're going to practice solving yields of chemical reactions. If you haven't checked my other video, please check that first. Okay?
Oh my god. Why am I already sad? Hi, I'm already like ready to cry. Maybe I do need a drink. Who knows? Maybe we'll get one like halfway.
So let's have this problem. 9.87 grams of ammonia react completely according to the following reaction. If 13.74 grams of urea are produced, what is the percent yield for this reaction? So let's analyze the problem. In the first phrase, we are being asked to compute for the theoretical yield because we have a complete reaction. In the second phrase, we have the actual yield. 13.74 grams are produced. Then we have to compute for the percent yield of this reaction. Let's solve for the theoretical yield first. Draw the table, put the given to the upper leftmost of the table, then use the molar mass to get the moles of ammonia. And then you have ammonia, right? You have to use the mole ratio. And we get the mole ratio from the balanced chemical equation, which is 1:2. So to produce 1 mole of urea, you need 2 moles of ammonia. Okay, now we have the moles of urea. So we will now use the molar mass of urea. You will put the mole in the bottom so that you will get the mass of urea in grams. Okay, cancel the units. This will give us 17.4 grams of urea because the given that we used has 3 significant figures. Okay, 9.87. Now let's solve for the percent yield. So we have the formula actual yield divided by theoretical yield times 100. That will give us 13.74 over 17.4 times 100. The final answer is 79.0%. Why? Again, we consider the lowest number of significant figures when dividing. That's why the final answer should have 3 significant figures too. Okay, so let's have another problem. 85.4 grams of chlorine reacts completely according to the following reaction. If 104 grams of phosphorus trichloride is produced, what is the percent yield for this reaction? Now let's analyze the problem. We have the actual yield, 104 grams, and we're looking for the percent yield. In order to get the percent yield, we need to have the theoretical yield first. Now to get that, we use the same method. Draw the table, write the given to the upper leftmost of the table. Again, it should be 85.4 grams of chlorine, not 104, because 104 is for the actual yield. Then we use the molar mass, grams in the bottom, to get the number of moles in the top. Then we have the moles of chlorine, we need to use the molar ratio. Since we have the moles of chlorine, we need to use the mole ratio from the balanced chemical equation. Remember, it's important to balance the equation first because this will basically determine your mole ratio. Then we will have 4:6. Okay, don't simplify it yet. Then make use of the molar mass, 1 mole of phosphorus trichloride in the bottom, to get the mass of phosphorus trichloride in grams. Canceling the units, boom, boom, boom. This will give us 110 grams phosphorus trichloride. But it's not yet over, right? We still need to compute for the percent yield. Just write the formula actual over theoretical times 100. That will give us 104 divided by 110 grams. Cancel the unit times 100. The final answer will be 94.5%.